vertex form. But first we have to take the square root. And if we take the square root of 0, we still get 0. Now we'll do the additive inverse. And we get that x is equal to 4. And just as an illustration, it is a double root, which means it will only touch the x-axis at one point. So we're going to start with the square root. We end up with a positive and a negative 14 when we take the square root of 196. So we're going to split this into two separate equations and then solve for x. How are you guys doing? This problem here, we're going to start with dividing 16 out first, simply because we can't take the square root, or we could, but not all problems are going to be as nice as this one. So we're just going to take it easy, and we're going to start off with doing the multiplicative inverse, which means we're going to divide by 16 on both sides, which is going to give us a fraction. If we do this correctly, we'll end up with the same answer. There's different ways of doing this kind of work. Next, we're going to take the square root. And last, we're going to add 3, but we're going to split this into two equations. Okay, this is funny. So this is negative 16 over 27. Now, think about it this way. This is already a divisor. It's a denominator, 9. And then we're going to divide again by a 3. So those are, the way I look at it, is like they're joining forces. So 3 times 9 is 27. And again, you can use a calculator. So this is going to be the same thing over here. So we're going to get x is equal to negative 2 over 27.
Here's number 18. We're going to start with the square root. That's the negative 5/4.
You're going to solve the equation using square roots, and you're going to round your solutions to the nearest hundredth. So first we're going to start with subtracting the 6 on both sides of the equal sign. That's going to give us the x squared is equal to a 2. 2 is not a perfect square. When we take the square root of both sides, we end up with 1x, and then we get this value 1.41421. This doesn't mean the number is bigger, it's just an irrational number, and that means it has no pattern. This number goes on forever, it doesn't repeat, it's an irrational number. So we are going to round to the nearest hundredth. So here is this one right here, that's the hundredths place. We look at the 4. If the 4 was 5 or greater, then we would have to round the 1 into a 2, but because it's a 4, so anything between 0 and 4, the value stays the same. So we're going to round our solution to be, and remember it's plus or minus, 1.41. On number 20, our first step is to add the 12 to both sides of the equal sign. That's our additive inverse. Now we're going to take the square root of both sides of the equal sign, and that'll give us 1x. I've got this irrational value, 3.8729, so on and so on. All right, let's round. So we look at the 7 is in the hundredths place. We're going to take a look at the 2 because it's between 0 to 4. This is going to be our answer right here. So x is approximately the positive and negative 3 87/100. Question 22 states that a ball is dropped from a window at a height of 81 feet. Here's your function, and it represents the height in feet of the ball after x seconds. How long does it take for the ball to hit the ground? First, you must understand that the height of the ground is 0, so this h will turn into a 0. And then we can go ahead and write down our equation. Most of you, to solve this algebraically, would probably subtract the 81 to the other side. I like to keep things positive, so I'm going to add this negative 16 instead. So now I have a positive 16x squared on the left side, and that's equal to an 81. Divide by the 16 so I can get that x squared by itself. So that's that multiplicative inverse. And now I end up with x squared is equal to a fraction. It's okay, you guys. And now we take the square root of that, and we end up with x being 9 over 4. Don't forget that it's positive negative. However, can we have negative time? And we're going to say that's a no. We can't have negative time. So we will only have positive 2 and 25 hundredths of a second. We're talking seconds. Problem 23. The volume of a cone with height h and radius r is given by the formula v equals 1/3 times pi times r squared times h. Solve the formula for r. Then find the radius of a cone with the volume of 27 pi cubic inches and the height of 4 inches. The first step I would do to isolate r is to multiply by 3. That will get rid of that fraction, and then we can keep going forward. Since all of these are multiplying, in order to undo this, I would have to divide by pi, and that makes a 1 here, and h. I'm going to do the same thing on the other side of the equal sign. The next step is to take the square root. So we're going to end up with the following formula. The square root and then 3v divided by pi h. So now we're going to go ahead and substitute in the values that they've given us so we can figure out what the radius is worth. All right, so I've gone ahead and substituted. What I want you to also be aware of is that pi divided by pi is 1, so those pretty much cancel out. So now we're just left with 3 times 27 divided by 4. And so we get 9 over 2, but that doesn't sound too good because this is a word problem, so we're going to say that the radius is 4.5, and we're talking in units of inches. And that is our answer right there, guys.
All right. It's time to practice. Move those arms. Come on. L, show me. Oh, yep. You in the back. Hey, pay attention. You're supposed to be paying attention. All right. Time for some practice. Move on to the next task, guys. We're almost done. Almost done. You got this. I believe in you.